Hello everyone, welcome back to another physics lesson. I'm Physics Michael, and today we are going to talk about the concept of acceleration. This concept is crucial for understanding how objects move and change their velocity over time. We'll cover three topics: changing velocity, the definition of acceleration, and acceleration in different situations. Let's get started. Before we learn the concept of acceleration, let's take a review about velocity and what is changing velocity. As we already know, velocity is a vector which both have magnitude and direction. So changing velocity happens if the magnitude changes, just like the car speeding up here. Or changing velocity happens if the direction changes, just like the car bending its direction here. Or changing velocity happens if the magnitude and direction both changed, just like the ball bounced back from a racket and moved with a lower speed in opposite direction. And if we want to find the change in velocity, we just use delta v equals v final minus v initial. It is a vector difference. So don't forget to include the directions in the mathematical calculations. Let's take some examples. First, a white car on the road is trying to overtake the other car. So it speeds up from 10 meters per second to 20 meters per second. The change in velocity is the vector difference between final velocity and initial velocity. So we just use delta v equals 20 minus 10. And the change in velocity is 10 meters per second in the same direction as its initial velocity. In the meanwhile, the other blue car decelerates or speeds down from 20 meters per second to 10 meters per second. And its change in velocity equals 10 minus 20. So the change in its velocity is negative 10 meters per second, which means it is in the opposite direction as its initial velocity. In the second case, a car makes a U-turn on the road, changes its velocity to an opposite direction with the same magnitude of 5 meters per second. Here we can use negative 5 minus 5 to find its change in velocity, and it is negative 10 meters per second. It is just opposite to the direction of its initial velocity. In the third case, a basketball bounced back on the floor, changes its velocity to an opposite direction with a lower speed. So both the direction and magnitude of the velocity is changed. Here we can use negative 2 minus 3 to find its change in velocity, and it is negative 5 meters per second. It is also opposite to the direction of its initial velocity. Then let's turn to definition of acceleration. Acceleration is defined as the rate of change in velocity. It can be calculated by change in velocity over time taken. Since change in velocity is a vector, so acceleration is a vector quantity as well, and with a unit of meter per second squared. Where we just use the formula A equals delta v divided by delta t, where A is acceleration, delta v is the change in velocity, and delta t is the time taken. For instance, a cheetah started to sprint from rest, trying to catch its prey, and it can reach a velocity of 20 meters per second in 2 seconds. In this case, the change in velocity is 20 minus zeros, and divided by 2 seconds, we get the acceleration of the cheetah is 10 meters per second squared. Here, meter per second squared is the unit of acceleration, and from this case, we can understand the meaning of acceleration. For example, 10 meters per second squared means that the change in velocity in 1 second is 10 meters per second. In simple terms, acceleration tells us how quickly an object is changing its velocity. By this 10 meters per second squared, we can infer that the change in velocity in 0.5 seconds is 5 meters per second. Or we can infer that the change in velocity in 2 seconds is 20 meters per second. And of course, the change in velocity should be in the same direction of the acceleration. Let's go through an example. Suppose a car is traveling at 10 meters per second and then speeds up to 30 meters per second in 5 seconds. What is its acceleration? We use delta v over delta t, and that's 30 minus 10 over 5. So the car's acceleration is 4 meters per second squared. Here, acceleration is in the same direction as its initial velocity, so the car accelerates or speeds up. Now, what if the car slows down from 30 meters per second to 10 meters per second in 5 seconds? The acceleration would be 10 minus 30 over 5, so it is negative 4 meters per second squared. Since acceleration is negative, it means that the acceleration is in opposite direction of the initial velocity of the car, so the car decelerates. Let's go through another example. Suppose a car is traveling at 10 meters per second and decelerates at the end of the road, and then it travels back on the same road with opposite direction with same speed of 10 meters per second. All this happens in 5 seconds. What is its acceleration? The acceleration would be negative 10 minus 10 over 5, so it is still negative 4 meters per second squared. Since acceleration is negative, it means the acceleration is in opposite direction of the initial velocity of the car, so the car decelerates and then accelerates in opposite directions. Now, let's summarize what we've learned today. First, changing velocity is just the vector difference between the final velocity and the initial velocity, where we just use delta v equals v final minus v initial. Remember, it is a vector difference, so it has a direction. Second, acceleration is defined as the rate of change in velocity. It both has magnitude and direction, so it is a vector, and it has a unit of meter per second squared. Third, acceleration causes change in velocity in its direction. This may cause different effects in different situations. That's it for today's lesson. Thanks for watching, and I hope you now have a clear understanding of acceleration. I'm Physics Michael, and I will see you in the next video.